Started the Java collection series. In that, we have seen the array list and list interface. So, in today's lecture, we are going to see the linked list. So, that implements the list interface and also the queue interface. More briefly, the queue input interface has one interface that we call DQ that implements the linked list. So, we will see the in today's lecture the linked list. So, let's start with the linked list. Just give me a second. So, so first start with the linked list definition. So linked list is a collection of objects called nodes. So if you see the first element, so we call as a node, and in that the elements are present with the addresses. And so if you see, and these nodes are randomly stored in the memory. So we store the element that if we see the free space, that element will store in that position with their addresses. A node contains the three fields in Java. So in Java, the double linked list is used, and in other languages, a single linked list or double linked list is used. But in Java, we have to use a double linked list, and it will store the addresses of previous node and after node, and one field is store the element value. So that is called element or their value. And if you see the first node and last node, the previous value of the first node is null, and the last value, last node, last address is null. So in the linked list, the first node previous value is null and last node value is null. So this is the representation of the linked list. And if you see the why we need the linked list, we have to insert the element, we have to delete or manipulate the element. So that is why we use linked list, because the manipulation occurs very fast, so we don't have to use extra space or extra time to manipulate the object. So that is a main thing. So that is why we use linked list mainly. Other than that, we don't have any that much what we say advantages of linked list. So that is why we use linked list. So that the first example is that we have initially a linked list that is 12, 52, 45, 78. And if you see the representation, the first node, the value is 12, and their previous address is null because there is no element present in the direction. That is why we use null. And after that is the next value of that is next address is the next node address that is present in the memory. So that will store in this field. And same with the second element that is 52. So previous address for of that node is stored in this point and this field, and this next field is store that the next node address. So same with this. And if you try to insert the 5 in the at position 1, so we have to insert element at this position. And if you want to store in the array list, we have to insert that element that position, and we have to move all the element to the right. So that will take more time. So that is why we use linked list. And in linked list, if you try to insert the 5 at position 1, so we have to just change the address of previous element. That is, if you see the address of 52 of previous address, that was 12, but if you insert the 5, so it will store the address of 5, and same the address of 12 after that is next, it is storing the address of 5. So that will change only the address, and after the element there is no change with the element addresses. So we have to change the element addresses only, so that will take less time. And same with the deletion. So if you see, so I want to delete the 52, that is position 2. So if you see, so I am going to delete this address, so I have to delete this address and I have to directly link this address with this, and it will directly delete this element, and I have to remove this address also. So it will directly link with the 45, and we don't have to change the other element addresses or position of there. So that is why we use linked list. So this is all about the linked list. And to see the implementation, how can we add the element or how can we use their method? So we have to see in the code base. So we will directly see the code. So to represent the linked list, we have to just give the linked list class, and we have to import that class that is present in the java.util package. And first we have to give data type, and if you don't want to give the data type, you have to just remove this, and it will treat it as a normal linked list, and we will give that equal to new linked list. So we don't have to give the data type, so that is why. And we can store any data type value. So like if I want to add 100, I can do that. If I want to add a string, I can do that, like A, B, C, and I can do that. And if you want to see the result, yes, I can store any value in the linked list. And to check the representation of linked list, we have to just go open declaration. So if you see, the class linked list has data type, so it is a generic type. It will extending the abstract sequential list. That means it will use what we call get method and size, that is a size method that is present in the this class, and we have to use in the linked list. So that is why we have to use this class, and we have to this class also provide the skeleton implementation. So if you try to insert the any value, it will give sequentially, like if you want to insert 10, and after that we want to insert to 20. So it will insert after the 10 directly 20. So that is why we use this class to give the more proper implementation. And also we use the interfaces like list. So we have this is the list interface. It will use list interface, and also we will using the queue, that is a DQ interface. Also the clonable, that means we have to use if you want to copy or anything we want to copy in the next list without changing the implementation that are present in the list, we can do that. And also one more thing, we can also use java.io.serializable. That means we can convert the data into byte. So that is why we use serializable. So linked list can be converted into byte. So that is why we use the serializable interface. So if you see the implementation of linked list, so first is a link first. So if you want to add the element at first, we can use this method. And if you want to add a linked list as last, we can do that also. So these are the methods. And if you want to link before, after, then unlink the first, that means we want to unlink and we want to move the head to the next element. We can do that. We can also unlink the last. Then and if you want to get the element at first, that means first element we want to get, so we can use the get first, and get also the method present in the linked list. And if you want to remove first, you can do that also, remove last. So these are all the methods present in the linked list. So generally we use the methods that is contains, then size, then add, and in add also we use index base. Like if you want to insert at index So we can do that also. And if you want to remove that, we can remove by using object, and we can also remove by using index also. And if you want to add all the element, like there is a collection present in the in list format, and if you want to add in the linked list, you can do that by using this method. And we can also remove by using collection. And if you want to insert at index of that collection, you can do that also. So these all are methods present in the linked list. So we will see one by one. So first of all, I will delete this and I will create with data type. So I will give data type integer, that is L1 equal to new linked list integer, sorry, integer, and I will add L1 dot add 100. That so we will see the example that is presented in this example. So first of all is 12, 52, 45, 78. First one is 12, then L1 dot add 52, L1 dot add 45, then 78. If you see, I have inserted all the element. So if I want to see the result, I have to use system.out.println. So if you see the linked list, so they have implemented toString method. So that will use the element and it will take the one by one and it will form in the square bracket. So that is why we use toString method to get the value. And if you do not use the toString method, so that will give the address that is present in the memory. So that will directly give the address of that linked list. So if I see L1 and I will save and I will print that, it will give in the that order. And if I want to insert element at position 1, so I will give the it is after before inserting, and after inserting I want to insert at position 1 value I am going to give 5. So after inserting 5 at position 1, so what is my, so I will see, if you see the linked list. So if you see the linked list, at position 1, it will insert 5. Without changing the location or any updation within other element, it will going to insert 5. And if I want to update the, what we say, element that is 5 at position 1, so I have to use set and I have to give the index that is 1 and I'm going to give 7. I'm going to update that. And if you see the list after update, that is L1, you see I have updated the 5 with 7, if you say. So I want to remove the element that is present in the position of like what we say, I want to remove 45 that will present at the position 3. So I think will deal with you, that is 0, 1, 2, that is the index of 2. So that will I will remove 45. So so I have to just stop this because it will add in the element also this. I just want to use previous, that is initial linked list. So I will remove. After removing plus L1, so this will take. If you see, I have removed successfully 45. And if you want to add the linked list, so I will see linked list integer, and I want to all the element present in this list, I want to this in the L2 linked list. So I have to use new linked list, and I am going to add L2 dot add. I am going to use index a collection, so that is L1. So if you see L2 linked list, I am going to stop this. So I'm going to updating the all the element present in the linked list, and I'm going to add in the L2 with using add all. So it will add all the element in the L2. Now I'm going to printing the L2 before, like if you see, so this is L1 and this is L2. If you see the L1 list and L2 has the same element present in the list. And also, if I want to remove the what we say element from the L2, it will remove all. So I am going to use the L1 linked list. It will remove all the element that is present in the L2. So it will give me the empty list. So before giving me this, so remove all. If you see the result, it will give empty. So that is the thing. And if I want the element that is present in the, if I want the element, we say directly. You can also store in the integer data type, and you can print that also. So I'm directly printing the first element. So that is 12. So that will print directly. And if I want to get last, that will also we will get. Yes. So I'm getting the last element. And if I want what we say want to remove the first element, so I have to just remove first method, and it will remove the 12 from the list. So sorry. So it will remove the 12, and if you want to see the list after removing 12, it will give. Yes, you can see that I have successfully deleted the 12. And if you want to remove the last, that means we have to just give the last. It will remove the last element. Yes, so we will have to remove last element. It will remove last element successfully. And if you want element that is what we say the element that is present at the index 1, so we just have to use system.out L1 dot get. By using index, we have to just give index 1, and it will print the element that is 52. So this is the things we have used all the elements that is present in the list, that is linked list. And if you want to get the size also, you can do that L1 dot size. it will give the size. If you see, the element size is 4. And if you want to use iterator, so like for loop, the advanced for loop. So I'm going to use the normal for loop. So we have to just use int I equal to 0, I less than. So L1 dot size I plus plus. And if you want to print, what you say, I, we can do that also. For integer, then we have to give variable name, that is I, and we have to use the which linked list, so L1, and we have to just print I. So it will directly print the element. And if you want to use iterator also, you can do that also. So this is all about the linked list. So tomorrow lecture we will see the about the queue and their classes. So we will see that in tomorrow's lecture. Thank you.